Not that I really care, but I hope it sounds good because either way it's going to happen. The test is through last week's material, so through Review 13. If you're struggling with anything in that region, please come in before Thursday, before school, after school, or 7th hour, and I will help you, okay? Okay, so we're going to exchange Saxon books today, and test is Thursday, and then we'll do some of the homework. I'll explain that in a minute, but for now, while I'm doing book checkout to get you going, why don't you do these two on the homework. The very last box is a infinite rectangle problem. Try that one, and if you get that one done, then you could also do number 3 on the back, which is find the absolute max of y equals x to the 2/3 on negative 1 to 2. While you're working on that, I will call you back one at a time to either take your old book back. If you haven't given me your Larson book, I'll take your Larson book, and either way, I'll give you a Saxon book. Okie dokie, here we go. Carla. Also, if you haven't given me your packets, make sure you give me that too. Oh, that's right. I'll get some. Thank you. Good point. Okay. Also, I ran out of book checkout forms. If you didn't get one when you came in, there's some back here. Carla, come on, what do you got? Sorry, I wasn't here. I already got your books, so you just need those. Yay, Sean. We're also start working on the book checkout sheet. Sebastian. I'm trying. Oh, yeah, sorry. Oh, here, I'll come to you. You're welcome. I'll serve you, buddy. I missed the one. It's okay. It's almost painful to watch you do it. Thank you. I'll get you a book. Thank you. You're welcome. Okay. Let's see. Macy. Your book or your book or you? Okay. Kyle.
I got 15. I got that. I did that, and I got it.
Marissa's not here.
I Lauren. Number 2.
Yeah, there's 27. Plus another one. You guys get 24.
I got 21.
Okay, so maybe I just so maybe I just get it.
Okay.
How do you repeat 21?
Wait, no, I got, no, 24.
Yeah. 6 plus 9 plus 9.
They said that you constantly rethink about
Is it 6 plus 18 over 2?
over time, the story, you check your problems like 5 times and you love it.
15 or 6 plus 9. Wait, Grace, you have to say 1 plus 1. Did you add some of this? Why is that wrong?
Because you're continuing to add, did you add the outside of it?
Yeah.
What is that? Just one, Elizabeth, you get it.
Wait, what do you mean you gotta add up? What?
It's positive.
Oh, I see.
Just bring your packet.
Oh, yeah.
Bring your packet.
Oh, no, I'm not ready. How do you know it's right though? How do you know it's right? Just this one?
Yeah, I think so.
If you want all the packets that you get, so you add from 1 to like the 3 I over.
Yes. And then you start with one. You're really talking about causing problems.
I don't have the big packets. Wait, hold up. Andrew, what did you because you're the add the 1. So this one, no, it's 3 I over n plus 1. Wait, are you sure you was 3 I Oh, just because you're adding that to the end.
You start the limit.
Oh, okay, so it's all of x squared. And so x.
What do you think the limit is? It's 1 plus. Because you have to add 1. Part of the function and it's not screen zero. So you just add 1. It's like 3x.
It's separate.
Yeah, so like how do you take the, what is the limit that wait for what? It's a 2n? Or is it
So it's 3 over n.
right?
6.
Wait, why did you do? Oh, it's 1 squared. I didn't realize that was an x.
Yeah.
I hate how these forms are right.
I think EVT, I think like
EVT is like,
CP and
like,
EP.
it's, yeah, you say like, if it continues.
Y is true on negative 1 2. So there must be an absolute x or something like that? Or not absolute x, there must be an x.
Yeah, don't you need x from where? Yeah.
1 plus 6 I over n plus.
Exact number of
Oh,
I squared is,
yeah. Plus 9 I squared.
see how you, what's, I don't remember what the state.
Wait, so I got
No,
to
you
use
just say y is continuous on the interval.
What'd you get for each part? 3 plus 9
And
is
then you
9.
can start with the end of the chart. And if I'm wrong, then I'm sorry.
Oh, I see.
And you,
Yeah, if I had this right at the beginning, it would be so good.
I don't know the process.
Mr. James.
Yeah.
So you take your
So you factor it out.
I would say ridiculous. They can factor, you just need to create like this fashion. Somebody wants I never end.
Yep.
That's why they made that. Oh, it's just double, like 1 rectangle.
where did you get 6 and 1? Just like,
6 ends up saying, I think.
I only had 6 over. Oh, you mean like after you forming that?
You mean the one?
Yeah. Ominous. No, like after you look at the. You know what I mean?
Yeah, that's right.
Hey, last homework. Said everything I've ever been in school. It's also. Yeah, it's supposed to be what I felt like the problems. Yes. No, it's not. I have one. Why did you ask me?
I don't check book covers, I just not that organized, but take care of your book, please. And it'll take care of you, as they say. Okay, while I'm on the subject of books, please turn to the inside cover of your book and put your name in pen on the inside cover in case you lose it in the senior lounge, whatever. Put your name on the inside cover.
I got Tyler Braun.
I will get you answer packets for the evens tomorrow. Sorry, I don't have them today. And you'll always have even answers for the book. I don't take class time to put those up. Okay. Now, how did we do on these bad boys? If this appears on your test on Thursday, how would you do? Would you receive full points? Or do you understand it so well that you're skipping so many steps that you actually lose points? Look at this. I would expect either one of these first steps, my rubric would have a point for either that or specific that. 3i over n. If I didn't see one of those two steps, you would have already lost the first point. One of those has to be there, preferably both. Okay, but at least one of the two. I then would expect you to show the function 3 over n, the function being blank squared plus 1, and in that blank going 1 plus 3i over n. Wait. After that, there's a little bit of gray area as to how many steps to show. The next thing I would grade for is the isolation for the purposes of using the formulas. So I would next drop down to check for, let's see, you have a 1 outside, so you might have something like 3 over n times a 1. And then you should also have a isolation of an I term. How many i's we got there? What's the coefficient out front? We'd have 18, was it?
18 over n.
18 over n squared I. Do we all concur with that? That's what it looks like to me. And then you'd have, this should be 2, huh? Should you have had 2 here?
Yep.
Okay. Why didn't you say so? Okay, 2. And then the square I squared term, what coefficient is out front of the squared term? Something like maybe 27 over n cubed. Okay. That's how fast you do that. Pull stuff out, separate the summations. That's up to you. That's the next thing I would grade for. 1 point, maybe 1 point there, definitely 1 point there. At that stage, then, you show the formulas going in. I do not expect you to memorize the formulas. I will give you the formulas. So you should have something like 3 over n times 2n plus 18 over n squared times n plus 1 over 2 plus 27 over n cubed and n plus 1, 2n plus 1 over 6. Are you starting to have those even memorized? Yeah? Maybe I should just have you memorize it. Nah. All right. So that would be a step showing the formulas going in. And then the last is evaluating the limit using M behavior. Your answer starts to take on something like 6 plus 9 plus 27 times 2 over 6 or something mathematically equivalent. What's your answer at the end of the day? 24. Okay, how'd that go? Great. Okay, looking at your homework. Oh, I didn't have these fast. When you get, let's see, which one was it? These, you'll see, let's see, there are 4 assignments here, so it's a bit of a mess, but those of you who turned in review 12, there's an EVT thing that some people did not do well, and so you better come test time. Oh, that's right. Pause from oh, these ones are okay, sorry, I know one is 12. Okay, when you get review 12, you might look at the back number 14 and see if you have the right idea. But the extreme value theorem, I'm a little picky about how I want this done. I showed you how I expect it to be done, and that's how I'll grade it on Thursday. So if you get an absolute max question, I expect you to start by saying where you're going to look. The absolute max must be at critical number or an endpoint. That's first point. If you don't have that in your work, you just lost the first point. That's the thesis for the whole problem. This is where I'm going to look. Okay, not just here I'm looking, it's where I'm going to look. That's the extreme value theorem. You don't have to look everywhere. You don't have to look where the derivative goes negative to positive. That's the first derivative test. You say, where is there an endpoint or a critical number? Those are special numbers that might be the absolute max. After that then, the endpoints, it doesn't take a genius to gather those candidates. Those are -1 and 2. What does take a little work is the critical points. Either here or off to the side, the critical points need to be found clearly. Critical points are where derivative is 0 or undefined. I need to see the derivative. What is the derivative? 2 over cube roots of 3 times 3, right? Or something like that. Equals 0 or undefined at x equal 0. You have a critical number that is in the domain of the original because the original was numerator. That 0 was in the domain. So you do have a candidate there at a critical point. You gather the candidates. Now you look at the attributes of the candidates. Which one has the greatest y value of the ones that are possible? What is y at -1? 1, I agree. What is y at 2? Cube root of 4. Is that more than 1 or less than 1? More than 1. If they were less than 1, then it wouldn't get bigger enough to get 4. And what about y at 0? 0. These are the candidates. We said these are the only places it can be. Here's the attributes of the candidates. Now we can conclude the absolute max. It'll be clear on the test, especially if it's an AP question, whether you should give me the x or the y or both. It'll say, find the coordinates of the absolute maximum, in which case that's obvious. It'll say, find the x at which the maximum occurs, in which case that's obvious. Or it'll be, maybe this is the one that's a little nebulous, but it'll be, find the absolute maximum value of the function. In that case, you give the y value, not the x and the y. Don't kitchen sink in it if it's clear what they're asking for, the y. This, I didn't give it enough words, but I intended for this to be, give me the absolute maximum value of y equals blah, blah. So, what is the absolute max value? What's the greatest y value? Cube root of 4. Now that is actually the bare minimum with the ADT, but preferable is because that's the greatest of the candidates. It's greater than the other two. Yes? Or you could say in words, because that's the greatest of the candidates. And that's pretty common in textbooks too. That's what I want to see. I don't want there to be anything on Thursdays. No, this is what Ms. Peter told me. This is what I want to see. You are aware. You with me? Okay. All right. So getting back into the book, at the end of the book, you're not quite. It's the end of the summer. It's the summer. You're almost out of it. You don't practice it a lot. So I want to make sure that you're good on a few ideas in set 69 and 70. I just put them together. It'll go fine. So box 2. Actually, pause for those of you who are new to me. I will do notes a lot of the times, and so you'll see notes when you come back there. But if I feel like it's a lesson that students haven't had trouble with, then I don't usually do notes on those days. I'll just say, let's do number 13 on the homework, and we just start doing homework problems. That'll be days when I feel like the extra practice is necessary. That said, if you feel like you want your notes to be complete, you may do those problems in your notes, and on the problem set you can just say this is in my notes. All right. So, if you would like to go to box 2, these are 2 integration by parts problems that I would like to talk about. However, if you really want your notes to be complete and you'd rather go to your notebook and put this in your notes, and that's fine too. Okay? Do you see where I'm at?
Yeah.
Okay. This is a big trap problem. It's a lot like this problem, in that they are missed all the time. This, when it appears, especially on the AD exam, the most common answer is not the correct answer. The most common answer is 1 over x. And you just chose the derivative, not the antiderivative, okay? The actual way to do that, so those that say, well, I know that's not it because that's the derivative, but what do? I don't know what to do. It's because it doesn't look like a product. People think, oh, what am I supposed to do? But it is a product because that's a thing. It's a factor. It is something, okay? And so, same deal here. Don't look at this as a non-product. It's a product. There are 2 things there. And so we can use integration by parts. And that is how you get through this. You must see it as integration by parts, although it doesn't really slap you in the face as use integration by parts. That's how it's going to be done. When you choose you want to make it a choice that you know the derivative of, and the integral that comes out is clear. So what do you think for you? What do you want to use for you? This idea, again, this has never failed me as far as choosing your best u. The best u is logarithms, which there isn't one. The next best u is I, inverse trig. That is a good choice for you. Let u be arctangent of x. That implies that the other part is the dv, which is, therefore, dv is just dx. To run this whole process, you then need their companions. If u is arctangent, then du is the derivative of arctangent, which is 1 over 1 cos x squared dx. Now, I most definitely do not expect you to do all that side triangle development idea within this problem. That's not necessary. You with me? Do you even know what I'm talking about?
Yeah.
Okay. All right. You don't need to do that. You can just go straight to the derivative. V is the antiderivative of dx, which is x. With our substitution, then, uv becomes x arctangent of x. I prefer to write the x first, so it doesn't look like arctangent xx. Arctangent of x minus, then I get x over 1 plus x squared dx. this is where we might start to do things a little differently. There are a lot of people that can probably, how do you integrate that? What's the technique? U sub. Okay, so, and then I heard a lot of miscanonical people say W sub, which I like. That's kind of cool. If you then want to formally W sub this, then you surely may. There are, however, a lot of people that can do this mentally. Would you like to talk about how you maybe could do this mentally? All right. So what's your U? 1 plus x squared. So what should D? If U is 1 plus x squared, which I know W, but let's just say U is 1 plus x squared. What's D? 2x dx, right? You don't have 2x dx there. That's unfortunate. What you really like there to be is an x. You'd like it to be 2x dx, yeah? Can I put a 2 there? As long as I balance with a half. Now that is another way to kind of do this mentally and say this would be a great U sub problem if there is just a 2 there, which you can do. You can put that there as long as you balance out front. If that doesn't work for you, if you have no idea what I'm talking about, please feel free to do a W sub. That's fine with me. Okay? X, arctangent of x minus the 1/2 stays. This would become 1 over u, the antiderivative of which is natural log of the absolute value of u. And then when you sub back for u, that's natural log of the absolute value of. And again, if that's just too much, then fine. Go off to the side and do a W sub. All right. That's your answer. What do you imagine a multiple choice might look like besides that, or back of the book answer besides that? What could it look like? Square root. In fact, with the negative, it could even be positive in the denominator. Yeah. Are you with me? No, that's not what I intended. Even that could be possible. So you have to be in mind of all the possibilities with the logarithms that can write the answer. You see? Okay. This one's sloppy because although it's integration by parts and the choosing U is not too bad, the sloppiness is from all the extra coefficients in there. So give that a go on your own and we'll go over it in a minute. Cool. Is anybody having trouble figuring out what to choose for you? General rule of thumb is if your new integral is worse, you chose better. Okay, the whole idea is that your new integral should be better. So, for example, you chose your u as e to the 2x, then your new integral would actually still be e to the 2x, and then you'd have 3x squared, or 3 halves x squared with it. It would be nice. And so that would say, second Mr. Chase. All right. So, assuming then that you use u as 3x, then dv is e to the 2x dx. What's v? What's the antiderivative of e to the 2x? 1/2 e to the 2x. Now, again, whether you w sub that or just do that mentally, it's up to you. If you want to talk about, again, how to do that mentally, we can do that. But otherwise, let's just proceed. uv is 3x e to the 2x all over 2 minus v du is 1/2 e to the 2x times 3 dx. So what did you get? 3x e to the 2x over 2 or something comparable minus, what's the antiderivative of the second? 3 halves or 3 fourths e to the 2x. That's it. Did you get it? Okay, I'll assume by your silence that everything's super. One more idea. Turn to the back side, please. Set 69 was integration by parts, so we've done that a little. Set 70 is a real weirdly placed lesson. It's the rules for dealing with limits, which normally would be the first week of calculus, but now you're dealing with it months after. It's really pretty straightforward. The only gotcha to this is what I expect to show work-wise. You'll get the right answer. The question is, will you lose points because you didn't show the work out? So, it goes like this. In box 10, find box 10 on the back, and set 70. Do you see where I'm at? I think it's towards the bottom, yeah? The idea is they give you this background information. F of x is some function so that as x approaches 1, the limit of f of x is pi. That's given. The question is then, what would the limit as x approaches 1 be of 2 times the function squared? Well, this is then to show why, you can probably see what the answer is going to be. What's it going to be? 2 pi squared, okay? The question is why? Well, to see what this is going to have to be, before I can do the 2 or the square, don't I really need to know what does this do? Well, that means you're focusing on first taking the limit of this, and then once you know what this goes to, then you can square it and multiply it by 2. Now, can you do that? The answer is yeah. Limit rules allow you to do that. You can figure out what the function part goes to, and then square or multiply by a factor. This is required work. Then you surely may go straight to the answer. I know this is 2 squared. Okay, so don't just give me the answer. Give me the work. That one little bit, it's not a lot, just a little step of work. That's all I expect to see. Okay? Here ends the lesson. That's it. Is that easier or what? Okay. Questions on set 13. How'd set 13 go? Apparently, or review 13, apparently I forgot to put the key online. Again. Sorry. But that's all right. We'll go over it right now. Here we go. Number 1. Some people, this usually breaks down into people that had their calculator radians and people that didn't. People that did would get the right answer, and that is that this is approximately equivalent to 1.8176 or 81. So I expect 3 decimals rounded or truncated, so could you give me 1.817? Yes. Could you give me 1.818? Yes. Can you give me more than 3? Surely you can. Okay, so as long as you give me 3 more decimals, something like that. The units, or the interpretation then, what did you say? All right, so you do need to tell me what it is. Change, I mean, your velocity times time is changing position. You also need to make reference to these. Now, whether you put the time frame first in your answer or last is up to you. It sounds like Clinton said displacement first. The car is displaced or travels. Now, would it be right to say the car travels 1.8176 miles? Why not?
That's distance.
That's distance. It doesn't have, I mean, it could have traveled 101.8176 miles that way, and then 100 miles back, in which case it definitely did not travel 1.8176 miles. So the car the car's displacement. Now here's where we kind of get a little dicey difference between calculus and physics. The car's displacement is 1.8176 miles. Calculus, they're a little picky enough to interpret the sign. So 1.8176 miles where?
Positive direction.
Positive direction or forward? I said forward. It's easier if it says right or left and you just know it's right, or if it's up or down then you know it's up. And then you always need to make reference to the limits of integration with units. So that has units, and then the limits of integration need units. From time equals 0, units on time, hours to time equals 7 hours. You can also put the time first, say from time equals 0 to time equals 7 hours, the car is displaced. Or you could say at time equals 7, the car is 1.8176 miles from where it was at time 0. Yes?
Did you say the first 7 hours to travel that?
Yes, you could. Yes. All right, this one was probably the one that cooped you out. If there was one that cooped you out, it might have been this one. Anybody get E? Yay, well done. Super, excellent. This is a pretty common problem in college textbooks, but I've rarely seen it on an AP text. So this is super cool. The idea for this section was to understand that fundamental theorem of calculus multiplies with when one thing changes. Now, I don't know if you understand the power of that. It'd be like if I said Elizabeth. Can you multiply pretty well? Okay, we'll see. You're going to multiply the two numbers I give you. Ready? Okay, 3 and 4. 5, 6, 7, 8, 9. Come on. Okay. So my point is this. It's hard to multiply when one of the things is constantly changing. Every second it's constantly changing. And yet calculus does that. That's why we do velocity. In algebra, you say, well, the car goes 30 miles per hour for 10 hours, 300 miles. Boom. But calculus handles, hey, the car's velocity is changing all the time. And yet you can still say how far it goes by saying, well, for this little bit of time, the velocity is this, times a small change in time. And then for this little bit of time, the velocity is this. And calculus is amazing in that sense. That's what's going on here. It says, find out how many people within 3 mile radius of the city. Here's the city. Here's the city. And you got the population changes as you go further and further out. Now, this actually happens all the time. It also happens with property value. There's this thing that everybody wants to live by, whether it be the city or the ocean or mountains. And as you get further and further away, it's less desirable, which is why nobody wants to live in Aurora, right? Because it's so far from the mountains. I mean, who wants to live in Aurora, really? We live in Lakewood. There's the mountains right there. This is prime real estate, what we're talking about here. But as you live further and further away, less and less people live out there, and that's why density is a function of a negative relationship with radius. The greater the radius, the less the density. The problem is that it's constantly changing, and so I can't even say density in this region because just from here to here, the density changes. It's changing all the time. But let's say we got started here. In terms of units, what are the units on f of r? You can think your way through a lot of these if you use the units law. It's people per square mile. Now, in order to get number of people, I probably then need to multiply that by how many square miles. People per square mile times number of square miles, and that would give me people, right? Well, people per square mile. What's the function for how many people per square mile? Yeah, it's F of R. It's the density function. That gives you people per square mile. Now's the hard part. All right, I know that in this region, the people per square mile is whatever, 2 people per square mile. But then I would have to multiply that by how many square miles in this blue area. Now it's tempting to say area by, pi r squared minus pi r squared, because that's how in algebra you would do something like that. You'd say the area of that little ring is just the difference between the two areas, right? You with me? It's actually not the approach. How do you find the area of that pencil thin thing? You guys got it, did you? Yeah, unwrap it. If you cut it and unwrap it, then it's really just the area of this line. What's this vertical dimension? See, it's tiny. That's how thick the pen is right here. Isn't that how far the radius changed from here to there? And so that's a microscopic change in radius, which we'll call PR. This length, like Kyle said, is the circumference. It's actually 2 pi r. So if I want the total number of people, I take how many people per square mile times the area of each little tiny circle, and that's 2 pi r dr. And then making tons of those calculations and adding them or summing them gets me the perfect number of relation. From where to where? 0 to 3. And that is where E is. Isn't that cool? It also works with property value. All right. So, cool function. Let's go on to this guy. This was a disaster. I trusted the book I pulled this from, and he had lame limits of integration. So his were 0 to 60, and I used 0 to 60. But I can't remember, did I change yours to 0 to 90? Okay, that's good. I'll use 90. I changed it for my next year version. I changed it to 81, so you could do this without a calculator. But we'll use 90 and use a calculator. All right. And then my goal is that you learn from this. And so, if I apologize if you didn't get that message, but this is what I intended to get out of this. It's a rate in, rate out kind of problem, okay? Yeah, it was 60, but I changed it. Yeah, in class I said change it. But I don't know if everybody heard it. All right. So, you've got some water in a tank. Some's leaking out a little bit, and then some's coming in. And so let's figure it all out. Did you understand what I was getting at with the graphic kind of thing here? My goal is that here you graph in and out separately. I represents rate in and L represents rate out. If you go to 90, let's go by tens, okay? The in rate, which I'll do in blue, was constant. 1, 2, 3, 4, 5, 6. I'm going to go with 8. This is gallons. This is gallons per minute. And this is minutes. Okay? That's the rate in. We. The leak rate, if you graphed it well, looks something like, is it concave up or concave down? Is it concave up? That doesn't really matter, but they meet somewhere about 64, so if I'm not mistaken. Yeah? Okay. Now, that's one way to approach this, is to let the rates be separate and compare. Actually, talk to me. What's going on in this time frame before 64? Yes, Amy.
Why isn't it going slowly down? It's leaking out.
Because it's a amount of, so it's not talking about the amount of water in the tank, in which case it would be decreasing. They're talking about how much had leaked, and at time 0, none had leaked, and as time goes on, more leaks. That's a good question. I see why you think that. So, what's going on from 0 to 64, and why? Is the amount of water increasing or decreasing from 0 to 64? Increasing. From here to here, the amount is increasing because, why is the amount of water in the tank increasing in that rate? Because the rate at which water is coming in is greater than the rate at which water is leaking out. Okay? Afterwards, because the leak rate then overcomes, I have these labeled in bad places. After that, the leak rate overcomes the constant in rate, and if it's leaking out faster, then the amount of water will start to decrease. Okay, so it's going to decrease after this because the leak rate is greater than the. You see? Now, that's one school of thought. Let them be separate and compare their two graphs. Another school of thought is to put them together into making one net function. And that's what I was getting at here. The second graph relate directly I to L. I minus in minus out. I minus L. In minus out. At, again, use the same scale, so it's about like tens and ones here. At times 0, in is blue, minus out 0. It's not leaking at all at the start. So what's the rate at which water is changing on the first one? 8. Okay, it's 8. Now, what will happen then as time goes on is the leak rate becomes greater and greater. So N minus L will start to decrease until at 64 they are exactly equal. So I minus L, if they're both equal, becomes 0. So that point would correspond to here. And then we'd start to fall. And the shape, don't worry about the shape. It's more important to me is above the axis or below. Now in this case, because I minus L is above the x-axis, again it's increasing here and then decreasing. And you could say that I minus L really is the net rate of change, net rate. Okay, you'll see both kinds of problems give one combined rate or two separate rates. How many gallons of water leak out? Do I want to take into account the initial condition? No. Do I want to take into account the 8 gallons per minute coming in? No. The only thing that matters is the leave rate. So from 0 to 10 of either L, I did call it L later, so you could call it L, or the 1/2 T to the 2/3, whichever you prefer. All that you're considering is how much leaves. That's it. And so I don't have my key in front of me, but that was 13.925 in units? Gallons. Okay. I guess that should be. All right, that's it. Check. I'm going to come down here for a beat. How many gallons are in the tank at time 10? Now that goes to all the effects on the amount of water. So how would you say part B, the amount, I call this amount at time 10? 50 initial condition plus the integral from 0 to 10 of 8, okay, minus 1/2 T to the 2/3 dt. That's one possibility. Could you also do those separately? 50 plus 0 to 10, 8 minus 0 to 10, 1/2. Can that be done? Okay. Could I also, what if you said 50 plus, it's 8 gallons per minute for 10 minutes. Could you just say 80 gallons in? Take away some number out. All of those are fine. Okay? Because it's a constant rate that allows for it. C, this one, first of all, I hate that they asked you to make it in terms of F, because F has already been, oh no, it hasn't, never mind. I'm an idiot, sorry, never mind. Why did I call it A? F of T is the amount in the tank. We can use our previous work as a reference. What did we first take into account? All right, we'll finish, I'll put the key online, we'll finish going over it tomorrow. You do not have to turn it in today. Have a nice day. Yeah.
So I finished.
Ooh, softball.
I know. So, but the videos, are the videos online? Because I think I've looked at other
Were you logged into? They're only visible if you're.
Are there like one?
Yeah,
Okay.
but as far as getting the link to the videos from my calendar, you have not or?
Oh, you haven't.
So how did you?
I haven't seen it.
Oh, maybe I just clicked on the link and I got it.
Okay, and so were you logged in?
I put it on like my Dropbox like email. And just like PDF so it's cool, whatever.
In Google. In Google, you go to Google first and log into that.
Well, I mean, I'm already like, yeah, I thought it was that.
So like go to Gmail and log
It's,
in.
oh. Either give me the book checkout or I'll get it from you tomorrow.
Oh, like.
Is it charged-ish? It's fairly straightforward. If it's not charged, sometimes it won't work. But we'll see.
Oh, really?
You're gonna be great. So,
Oh, I need to stop.